I'm Cullen Owen, a field engineer for GigaIO, and in this video I'm going to go ahead over a little show and tell of what you may see with the GigaIO FabreX solution in a rack environment. Here I have the GigaIO RS4024 Gen 4 switch. In the middle I have our APA, our accelerator pulling appliance, and on the bottom I have a 1U server. What I'll be showing here with some layout of cabling and also demonstrating some of the LEDs, we'll be showing this as a standard topology, which is going to be a one host and two downstream devices all connected together. So with our equipment currently looking at the rear side, prior to the cabling, I'm going to show the typical layout that you may see in a data center rack. The switch being a top rackable switch, the APA appliance being possibly in the middle or the lower end of the actual rack, and depending upon the models of the 1U servers, this server will be the host connected to the environment. Now that we have our equipment, we're going to show a standard topology that most customers use. This is a 2-host by 4 downstream device topology. In the first set of ports, we have by 16. This is a host connected with 4 cables running at PCI Gen 4 by 16. These 8 cables are set for downstream devices. These cables go down to our APA storage device, also each at by 16. This solution shows the complete package of the GigaIO FabreX solution, which shows the host, downstream devices through the switch, and all devices inside the APA, up to 8 GPUs, will be allocated to this host. Next, we're going to show all the equipment powered on that shows the LEDs and the state of the host and downstream devices, along with the LEDs of the retimer cards in the back of the APA. In this video, we're going to conclude with the cabling with the equipment actually on to diagram the actual layout of the LEDs, the equipment, some specifics about the equipment that you may encounter in your data center. To begin, we've got the GigaIO switch on top. We have the APA, GigaIO APA in the middle, and we have a host server on the bottom. We're going to go through the typical scenario that you would encounter. In terms of power up, this is the GigaIO APA that would be powered on first. We have our switch that would be powered on next. And last, we would actually have the host that would be powered on. So to begin, we've got our accelerator pulling appliance. For these are our retimer cards that are connected as the actual target card. And in terms of numbering for the ports, for these cards we go 1 through 4 bottom up. With this card on the left handling the left drawer and devices, and this card on the right handling the right drawer and devices. These cables are connected to the switch in DSP downstream ports, with this left side going to these ports 9 through 13, and this right retimer card going into the ports 13 through 16. Then next we have the actual switch, which gets powered on, and the switch will show us the current state of the downstream device. The GigaIO switch currently has one power supply plugged in, and with the actual host and the downstream devices connected, we're going to go through some of the LEDs that you're currently seeing. The host was booted up at a by 16 connection into the first 4 ports on the switch, which is at by 16. The LEDs currently are showing us a link-up state at by 8. What this is signifying is there is a loose cable, or a cable that may have a malfunction, thus dropping the by 16 link to a by 8 link. These ports, which are showing our downstream device, the APA, should also be connecting at by 16. Here I've got ports 13 through 16, which show a proper by 16 connection. However, the ports 9 through 12 show that 2 ports are linked up at by 8 and 2 ports are currently not connected. In this case, 2 of the cables are actually not securely fit. The host is the last piece of the environment that we tend to bring up. And with the host, we have our GigaIO FA4004 card in host mode. That card does have the respective port numbers 1, 2, 3, and 4, and that also follows the suite of plugging into ports on the switch. So for this typical solution, we have our GigaIO APA, with currently 2 out of 4 power supplies connected, 2 retimer cards connected, with each one connected at by 16 to our switch. And then we have our host connected in the first 4 ports which was intended to be at by 16, showing us it's actually currently linked up at by 8. This standard topology is used within the field for many customer applications, and hopefully this gives you a good layout of what you could expect when seeing this fully racked up and operational in your data center environment. This concludes the actual physical layout of the GigaIO equipment. Please see GigaIO.com for additional videos and continued documentation on our solution. Thank you.